Yeah, we
All
can
right.
hear you.
All right. So for the multiplication, let's say you have matrix if, the notation for matrices, you remember that for vectors, we say it's going to small letters and arrows on them. But for matrices, they are capital letters. They use capital letters. So there's A, B, those capital letters. That's what we use for matrices. So the way we write it, like matrix A is equal to the big parenthesis 2035. So let's use this one. So this is a matrix A. For let's say you have matrix A, they ask us to find 2A. So that's this one means that you are using the number 2 to multiply the matrix. If you are doing that, the 2A will be equal to, you just multiply each element in the matrix by that number. So this one will become that 2 times the 2, each element should be multiplied by that number that you have. This one is 2, this one will be 4, 6, 0, 10. That's if you have one number that's multiplying the matrix. Use that number.
Do you still call that one also as a scalar?
You mean the single number?
The single number 2.
Yeah, every single number is called a scalar.
Okay.
Yes. So this is, you multiply the matrix by a scalar, then you just make sure that you multiply each element by that scalar. So where it actually gets interesting is when you are actually multiplying two matrices, and there is a condition for two matrices to be multipliable. I don't know even now that's even a word. So let me say matrix B. Let's say I have this matrix 3, 0, 1, 1. Remember that for addition and subtraction, the matrices should have the same size. The size for this thing is 2 by 2, and the size for this thing is 2 by 2. So these two can be added and subtracted. But would they be multiplied? Are they multipliable? Like as I was saying with my new word. So for two matrices to be multiplied, so let's say they say like we should do AB. So we should find AB, like A multiplying B. The way it should be done is that before it can be possible, is that so you use this, you look at the sizes first. So you know that A is 2 by 2, B is 2 by 2. So what happened is that before they can be allowed to multiply, you should make sure that the column for the leading one, is the same as the row for the preceding one. So A is 2 by 2 and then B is 2 by 2. But if the condition for them to be multiplied is that the last number for the first one, the last size number for the first one should be equal to the first size number for the second one before they can be allowed. So something like 2 by 1 can be used to multiply 1 by 2 because this last one is equal to this one. But if you have 2 by 3 and then 4 by 5, this cannot be multiplied. These two cannot be multiplied because the 3 is not the same as 4. Do I need to go over or it's okay?
Repeat it again. I think I understand, but I mean, just repeat.
All right. So before you can multiply two matrices, you should first look at their sizes. For the sizes, look at the column. The column for the first one should be equal to the row for the second one. That's the condition. So basically what I do is that I write them side by side. Once the two numbers that are closest to each other from each are the same, then we can be multiplied. So in this case 2 is here and 2 is here. Therefore these two matrices can be multiplied. If you come to 2 by 1 and 1 by 2, 1 is here, 1 is ending this one, and the beginning of this one is that one. So then the two matrices can be multiplied. But for this third one, 3 is ending this one, but 4 is starting this one. 3 and 4 are not the same. So these two matrices cannot be multiplied. So one example is that it doesn't mean that the two matrices can be, commutative. So let's say we have a matrix that is 2 by 3, and then the other matrix is 4 by 2. Let's say this is matrix A and this is matrix B. You can see that if you want to do A multiplying the matrix B, so that is going to be like 2 by 3 against 4 by 2. This is not possible because the ending of this one is not equal to the beginning of this one. But look at something. If we swap these two and we rather want to do B times A, it means that the B is the leading one, which is 4 by 2, and then A is 2 by 3. So when you swap them, then the ending of this one is the beginning of this one. So therefore, BA is possible, but AB is not possible. Is that my screen? All right. Please, is that okay?
Yes, please.
All right. So now let's go to how to do the calculation. So the very first step is to identify that the matrices are multipliable by looking at the sizes. So this is a 2 by 2 against a 2 by 2. So this one is just simple. We'll use this one for the illustration. So now for us to do the multiplication, so we are doing AB or BA because either way it will be the same. So I'll just change different numbers. No problem about that. So let's say we have two matrices that we are multiplying. So the first matrix is this one, 3, 5, 1, 8. So that's first matrix. That's multiplying another matrix, 3, 2, 1, 1. All right. Before even that, you should be able to know how the size of the final, the output. So when I did 2 by 2, right, against 2 by 2, you know that these two guys are the same. That's why they are multipliable. Now, if you cancel them, the result will be 2. This outside 2 by 2 by the size of the final or the result will be 2 by 2 as well. Let me use a different example to do that. Let's say you have 3 by 2 that we are multiplying against a 2 by 4. So what will be the size of the final one? That will mean that we know that because this side and this are multipliable, are the same, then the matrices are first multipliable. So we know that this will cancel out. Therefore, the resulting matrix that we'll get at the end should be a 3 by 4. That's what these guys. So these guys will be help you. The remaining one will help you to predict the size of the final matrix. So if I have 3 by 1 against 1 by 5, it means that the final product, this and this are the same, so they can be multiplied, but the final matrix will be 3 by 5. That's how you predict the size of the final matrix that we are going to get after the multiplication. So for this case, it's 2 by 2 against 2 by 2. So the final one will definitely also be a 2 by 2 matrix. So how do we do that multiplication now? Let me use the blue. All right. To do this, what happens is that this is where we need to be really, really careful. We know it's going to be a 2 by 2 matrix. The result is going to be 2 by 2 matrix. Let me say equal to 2 by 2. So there will be one element here, one element here, one element here, one element here. So we need to find this first element, find this second element, find this third element, and find this fourth element. So we need to start one by one, right? So what you do is that you take, for us to find this first element, we take this row, the row, to multiply this column. So it's row against column. This row, this first row of the first matrix, we need to multiply the first column of the second matrix. And then after that, it's as if you are doing expansion. After you do for this one, you use the same thing to find for, you use the 3, 5 to also multiply this side as well. So what I mean is that for us to find this first element, we use the first row, the top row, because it's at the top row. We use the top row to multiply the column of the second matrix. That will give us the result for the first one here. If you want to find this second one, we are going to use the top row to multiply the column of the second one. So if you notice, these guys are they are the top rows, so we are dealing with the top rows. So this is for the final one, we are finding the top row element of the final result. So we are using the top row of the first one to multiply each column, right? So if you use 3 5, 3 5 will multiply 3 1 first. That will give us the first element. The same 3 5, which is the top row of the first one, to multiply 2 1. When we are finding the down rows, we'll now be using these guys to do it. We'll use 1 8 to multiply the same column 3 1 to find this, and then that same 1 8 to multiply the 2 1 to find this. Let me go over that again. So for matrix multiplication, it happens in such a way that first we predict, how the final result will look like, but we are looking for the first element. We are going to find the top row element first. To find the top row element, we use the top row of the first matrix, which is this one. Let me use another pen. Right, so we use this top row to multiply this one like this. That will give us the first result here. The same top row to multiply this one to find the second element here. When we are done with that and we want to find the down row element, we use the bottom distinct row to multiply each column again, and then we'll put the right result at the right place. All right, let's see how we do the multiplication. So we use the 3 5 multiply against the 3 1. So let me pull that out and say it's 3 5. That's going to be multiplying 3 1. So how that is done is that we use this. So among the two, to do the multiplication, we use this to multiply this, and we use this to multiply this. Then we add them. That's how they are. But the way I do it is that when I pull them out like this, I have my 3 5. I know I'm multiplying this row by this column. So this column, I come and place it below it like this. 3 1. This is on my jotter or somewhere for me when I'm quickly doing it. So 3 5 is here. That's the top row. I'm using it to multiply this first column. So but outside of that, I put it on my jotter 3 5 against 3 1. So what I do is that this and this will give me 3 times 3 will give me 9, plus 5 times 1 will give me 5. That will be equal to 14. So the first result here is 14. The first result here is 14. So I'm going to do the same thing to find the second element. So what happened is that I still have the top row, because I'm finding top row element. You always use it because you are on that row. You use that row of the very first matrix. So 3 5. I'm done using it against this one to find the first one. So I'm going to use this one against the second row. So for that matter, I'm cleaning this, and I'm going to do the same thing. I'm pulling this column out, and I just generally put it under it, so that when I'm doing the multiplication, it's 3 times 2, that is 6, plus 5 times 1, that's 5, and that one will give me 11. So the second answer here will be 11. So it's 14 11. Then we are going to the bottom. We are going to the bottom now. So for the bottom 1 2, we know we are finding this element at the bottom, so we need to use the first row, the bottom row of the first element, and you do the same thing for how we did for the first one. So let me clear this side. I know my top row is, my bottom row is 1 8. That's what I'm going to keep as a constant. But to find this element, I need to bring the first column of the second matrix. That's 3, 1. So if I do that, that's 1 times 3, that's 4, plus 8 times 1, that's 8, so giving me 12. So the bottom here is 12. So I'm going to do the same thing and then multiply. So that will be 2, 1 at the bottom here, right? 1 times 2 is 2, plus 8 times 1 is 8. The answer is 10. So here, therefore, this place is 10. So this is the result of this multiplication. So you can see that at the end, this is also 2 by 2 from the predicted size that we got.
Francis, the 12 isn't it 11?
How do you get the 12?
I think it should be 11.
The 12, let me see. We have 1, 8, and then what? Against 3, 1.
It's 11. It's 12.
Oh, yes. You said
It's 12, right? Or
1, 8 against
11.
3, 1. So that's 3 plus 8. 3
okay,
plus 8, that's 11. 11. Sorry. All right. So what we'll need to do now is let's not use a 2 by 2 matrix. Please, do I need to clarify anything, or it's okay? Or we should solve more example to see.
we should solve more example. I think the clarification is fine.
All right. So let's use a different matrix. I want to use a 3 by 2 against a 2 by 4. Yeah. I want to use a 3 by 2 against a 2 by 4. So 3 rows, right? That's 1.
So Francis,
Yes.
in case you are given a matrix A and B whereby the sizes are not the same, like 3 by 2 and then 4 by 2. In that case, it's not multipliable. Is that not the case?
Yeah, 4 by 2. Yeah, this 4 by 2 depends on the order they give you. If they give you to multiply,
If the order is reversed here, then it's multiplied.
So with this particular one, 3 by 2 and then 4 by 2, is it multipliable?
no.
No.
So in that case, no, what will be the answer? You just say 0 or you have to explain.
Undefined is not possible.
All right. Okay, that's fine. Is that the fact I wanted to confirm?
All right.
Serious student.
Okay. So right now I want to give an example that it's 1, 2, 3. I mean it's 3 by 2. So 3 column, 2 rows. 1, 2, 3, 4, 5, 6. So this is my first matrix. This is a 2 by 4. So I'll just do 2 by 4, right? 2 rows. 7, 8, 9, 10. 1, 2, 3, 4. So that's, this is 2 by 4. That's correct. So these two are multipliable. So it means that what I'm expecting to be the what did I do? I think this is 3 by 2 against
And this 2 by 4.
it will be, the size will be 3.
Result is 2 by 4.
Yeah, 3 by 4. So we are expecting a 3 by 4 matrix. So since I'm expecting a 3 by 4 matrix, 3 by 4. So I'm expecting something here, something here, something here. 2, 3, 4. All right. Okay, so let's now start the
So
calculation.
do you have to have this the final answer in terms of the way you draw it in mind, or when you start you will be able to tell?
But when you start, you should be able to tell. But yeah, means usually I try to put it down, then I feel it. So if anything is missing, I know I did a mistake somewhere. But yeah, once you have multiplying it, it's okay. All right.
Okay.
So now we are going to look for this first element. We are going to use this first element. Remember, this is at the top row. This is the top row. So because it's the top row, we are going to place down the top row element of the first list. That's 1 and 4. So now for us to find it, we used to use the first column of the top row. So we need to use the first column. So the first column is 7 and 8. So 7 and 8. That will give me 7 plus, hey, this is 32, right? So the top is 39, I guess. Yeah, 39. So we have 39 here.
I think you are moving a bit fast.
Oh, okay.
Yeah, because I'm writing at the same time. So
All right. So you understand that I place 1 4 here, right? That's okay.
Yes, it's okay.
Then I place 7 and 8 down. Then I'm just 1 times 7, that's 7, plus 4 times 8, that's 32. You add them, you add the 7 and 32, you have 39. That's what I place here. So for the second one, we are looking for this one, so I'll use the second column. That's 9 against 10 here. So 1 times 9, that's 9, plus 4 times 10, that's 40. So this.
Please, wait.
All right.
So you are doing it for the. Are you doing it for column 1, row 2 for the second matrix? Are you doing it for the 8?
I'm doing is 9 and 10 column. The column is vertical. Vertical. So what you do is that you are just taking the first row.
Okay.
So we place the first row down, because we are placing the top row down because we are finding the elements in the top row of our final matrix. So you see that the second time when we are in the middle row, we'll be picking the middle row down, and then we'll be using the columns against them.
Okay.
Yeah. All right. So we are placing 1 4 down. So I'm going here. I did 1 4 for this. I'm going to put 1 and 2. So what I have is now 1 and 2 from this one are coming. Then 1 times 1, that's 1, plus 4 times 2, that's 8. So the answer is 9. So we'll place 9 here for the top row. Then we'll go to this one. We place, that's 3 and 4. So 1 times 3, that's 3, plus 4 times 4, that's 16. Then the result is 19. So 19 is here. So we are done with the top rows. So we use the top row of the first matrix, put it down to do that. Now we are going down to the middle row to find elements in the middle row. So for that reason, we are going to use the middle row element of our leading matrix. So I'm going to clear everything. We are doing the same procedure, but this time we are using 2 5. So I'll put 2 5 down, and I'll go to the same thing now, but the result will be placed in the middle because we are dealing with the middle, guys. And we'll do the same thing through every element in the same column. So whenever you use this element in that column, we'll add it here. In this column, we'll add it here. We're going to add it here until we are done. So this is 7 and 8. So 2 times 7, that's 14, plus 5 times 8, that's 40. So that's 54 in all. So I'll place the 54 right here. 54, because middle row, column 1. So that's what we are placing the results. Then the same thing for, that's 9 and 10, right? So this is 9 10. So 2 times 9, that's 18, plus 5 times 10, that's 50. So that will be 68. Yeah, 68 here. The same thing for.
Can you leave the last two for us too?
All right.
Yeah, this.
Yeah, the remaining ones, yes.
Twelve, 26, 67, 87, 15, 33.
Hey, Charlie, we beg you.
So you said
Is it 57?
Charlie,
it's 12, right?
12 years.
Uh-huh.
Yeah, 26.
26,
26. Then 67.
67,
87.
Hey, how
87,
did you finish the other one quickly like that?
15.
15,
33.
33. I didn't put into red bar because I want the others to also confirm. Yeah,
Oh.
but this is what we have. Let's see how it goes.
They are business students. I'm a science student. That's the difference.
Hey, Charlie.
Jerome, I'm asking if it is 67 or 69. I think it's 69, so check.
21 plus 48. Oh, okay, 69. Yeah. 21 plus 48. Yeah.
I go with your answer.
Then I'm slow, Papa. I see. Please, did you have 97 somewhere?
No, they had 87 somewhere.
87 rather. Okay. 9 times 3 is what, 27. Okay.
Mm.
That's 87. Mm. 6. And then 15. Okay, that's correct. That's 2 plus 3 is 8.
Charlie.
33.
Okay,
Okay, I've gotten it.
Hello, Francis.
Yes.
And network. I'm asking that with the same matrices.
Hmm.
For addition and subtraction, it's not possible, right?
No, it's not possible.
For them, they must be of the same size strictly.
Yes. Just like how we did for 2 by 2. If we're having 2 by 2 and against 2 by 2, that one addition, subtraction, and multiplication can work.
Yeah. This thing, it looks like simple, but the way you would have to.
Yeah, it requires a lot of work. That's how it is.
Yeah. But I'm surprised how, Jerome, what did you do that you were able to get the answers quickly like that?
How? First, let's continue. I want you to show me my workings.
Yes.
All right.
You do.
Let's. I will just take. I think we need to this multiplication thing. We need to solve from scratch, right? So I would like to take 2 matrices to multiply from each person. We put it on the board and we all solve it and mark it, everything.
Exactly.
Yeah.
I think that will.
So let's put. I'll put this.
Please, can you give us when you put it on the board? Kindly give time so that these people who mention answers and leave me behind.
Oh, okay. All right. So what will happen is, I'll start. I mean, anyone can start. Give me your first 2 matrices. That'll be the first exercise. And also keep in mind that they should be multipliable.
They should match.
Yeah.
So the first, I'm doing 2 by 4.
Hi. Okay.
So I'm doing 2 by 4. So I'm doing 1, 4, 3, 6. and then I'm doing 5, 1, 2, 7.
Against.
Then so 2 by 4 against 4 by 1.
All right.
So I'm doing 1. I'm doing 3. I'm doing 5, and then I'm doing another 3.
All right. So this is the first one. Question number 1. Yes. The next person should just give me another.
So somebody else will give that. Jerome, you or David, you can take it.
I think you are mentioning or
No, I've mentioned one, so he said you should mention another one, which matches.
I'm
I should
good
give.
with
Or I should give.
you can give.
Okay, so I'm giving 3 by 2
Okay.
against 2 by 3.
By 2
3 by 2
against.
against, yeah,
All right.
2 by 3. So with that one, I'm giving 5, and then I'm giving 2. And then I'm giving 6, and I'm giving 0.
Right.
I'm giving 7, and I'm giving -1.
Right. Yeah, we didn't use any negative number. All right.
Yeah.
And
Then
multiply.
for the 2 by 3, yeah. So for the 2 by 3, I'm giving 2, 3, -5. And then I'm giving 5, 0, 0.
All right. I think these two are okay.
Okay.
Okay. It's 1353, right?
Yeah, 1, 3, 5, 3.
Are we solving?
Yeah, we are solving.
I'm writing. Okay. Me, I'm just writing the question down.
Actually, I'm supposed to say this you exactly that's wrong. And I hear that. That's so papa or baby. Obedi. And two more baby. Yeah. Let your boy. No, I have. Back.
Marcin. Also.
Yeah, Patrick. And that dinner you
Yeah. Man, family reference. In here reference.
David, we can hear you.
Oh, sorry.
Okay, I'm done with the first one.
What do you get? 4639.
Yeah, 4639.
All right.
Twenty 15. Francis. Hello, Francis.
Uh, yeah.
Jerome,
Oh, I
what do you get?
muted myself.
2015 negative
Uh,
25.
yeah, 2015 negative 25, 12, 18
18
negative
negative
28,
30.
11, 21 negative 35.
Hmm. Yes.
I think my network is lagging. I don't know. These days, no, in the evening, no, this network is falling.
So the first answer is well, it's supposed to have a two. This is 4 by 2. No, this is three
It will
by
give you 3 by 3. It will give you 3 by 3 matrix.
the first one
So you mean the first one? Or there is 2 by 1.
by 1. So I think
Yeah, and that will give you 4639.
all right. But the second one, I think that's what Brad Jerome was mentioning
Yeah, that's 3 by 3.
by 3. So
2015 negative 25.
uh-huh.
12 18 negative 30.
Negative 30.
Yeah. 11 21 negative 35.
85. Please, can we all confirm? Is there anything missing?
I think that I almost got the same thing, but there is a difference.
Where?
So I got the same thing. I also got 20, 15, negative 25, 12, 18, negative 30. But I got negative 9, 21, negative 35. So I don't know. The negative 9, I don't know where
It's at this
maybe
side.
there's a problem. Yes.
40 minus 5 is what?
40 minus
40 minus 5 is negative, is 9.
Then it's 9. It's not 11.
All right.
Yeah, it's 9. Yeah, right.
So yes, so I was just confused about that. Jaron, can you confirm?
Come again.
Can you confirm the answer?
That is correct.
Jaron, or we should move on.
Maybe his network.
Yeah, let's continue. Let's continue.
All right.
Okay.
So that's the operations on matrices. The next one will be determinants of a matrix. But for determinants, the only thing that we need to worry about is it should be a square matrix. We only find determinants for square matrices. If not, you will not. Like it only applies to square matrix. So determinant is I don't know how to say it, but at the end, when you find a determinant, you are going to get one value. You guys, you remember when we were doing the
Dot-
cross? No,
Dot product.
the cross product. The cross product where you have
Yeah,
the
the cross
IJ,
product.
IJK and all that. That's where we are going to use something like that. For determinants, let's start with a 2 by 2 matrix. So let me start by 2 by 2 matrix. Let's say 3, 2, 1, 5. So the way it does is that it's the same concept, like the same stuff. For determinants of this, we are going to use this will multiply this minus this will multiply this, just like how we did it for cross
Okay.
product. Cross product.
Cross product.
So that will be 3 times 5 minus 2 times 1. So the answer would be 15 minus 2. That will give us 13. So for determinant, we are expecting a value. We are expecting a value to be given us. What happened right now? Okay. Yeah, so for the determinant of this 2 by 2 matrix, that's what we have. So now let's extend it to a 3 by 3 matrix where we see the difference more, or the applied whatever more. Is there any question? Is it okay?
Yes, please.
All right. So
Okay, so can you use like a 3 by 3 matrix? Let's see.
yeah, that's what we are going to do.
Okay.
I want to this thing, put this in on charge quickly. And ooh. Please a minute.
Okay.
Yo, amaya. Me gonna damore moto an. Me le magbolo. Adam moto nya. Awala ndaria. Okay. Awolo. Bona. Wa. Youth meeting. Oh, all right. My guy on my. Okay, now I. Okay, actually, you are. Oh, Mazanga go out. Go work fast. Oh, my God, we. Where am I? Yeah, 3x3 matrix. I think I like working with random numbers. So I do 2, 1, 3, 3x3, 4, 6, 5, 1, 1, 1. So let's say this is an example of a 3x3 matrix. Now for the determinant, so when they did, you remember these symbols, right?
I think your line is breaking a bit.
All right. Please,
Francis.
can you hear me now? Hello?
No, your line is still breaking.
Okay, good. On your line.
Please, can you hear him? Because it's breaking at my end.
But I can hear you, Francis. Even though my network.
Yeah, I can hear him.
I can hear you.
All right.
Oh, okay. Then maybe it's from my end.
Yeah. So you guys remember this symbol that we had like for vectors? We have it like this. Then we know it was for magnitude.
Yes.
But for matrix, when you see it around matrix, they are asking you to find the determinant. When matrices are capital letters, so when they ask you around matrices and they put this in around it, it's not for magnitude, it's for determinant. You have to find the determinant, and that matrix should be a square matrix before you can be able to do that. So in this case, we are still with how do you call it? Our matrix. So what happens is that let me clean this side. Yes. So now we have to find this matrix, right? The determinant. So let's say this is matrix A, and they ask us to find this. So it means you have to find the determinant. To find the determinant, we have to go back to our cross product.
Is the matrix A, is it not supposed to be equal to, or like it should be like the way we write vectors?
No, it should be equal to. Sorry.
Okay.
All right. Now to find the determinant, that's when we go back to our cross product thing that we did. So, but what we have to do is that, you see, this one is plus, minus, plus. We are using the first rule. Our consideration is going to be on the first rule again, where we'll do this against this that we did last time. So what it's doing is that the number that we are focusing on is 2. So 2 is the center point here. So what happens is to find the determinant, sometimes they will write it like the det A. Sometimes they will say det A. So that's the determinant of A. Be equal to this number that we have, which is 2. Right? We'll multiply. Let me even, to make it easier for you guys to relate to it. You remember if when we were doing I, J, K, then we had, let's say 2, 3, 4, 1, 0, 5. Then we do that thing for I. We do it like this because we want to find the element of I. Then we do 3 times 5 against minus 0 times 4. So then after that, we'll attach it to I. We'll attach it to I. So let's say, let me solve this one. That will be like 3 times 4. That's 15 minus 0, because 4 times 0. Then there will be 15. Then at the end we say this is 15I plus something this in. So this I nu that we have nu, this is what we had for the vectors time. Do you remember? So
yes.
Now this I that we have here, this I that we had over there will also be a number in this case. So for this particular case, this thing that we are seeing the 2, we are crossing against the I. The I will be the 2. So when we are done with whatever you do, you multiply it by the actual 2. All right. So with that in mind, because we've done vectors already, so it's easier to. Okay, Charlie. Um. So this one, that's what I'm doing the 2 into brackets. Then this time is this. This time is this. Minus this time is this. So it's always major diagonal minus the minor diagonal. That will be 6 times 1 minus 1 times 5, which is 5. Right, that's the first thing I have. Then this will give me what? 2 times 1, which is equal to 2. That's the first thing that we get. We'll keep this number first. Then we'll be adding it to the rest that we will find as well. So we found for this one. Then we'll do the same thing for, you remember that when we were on J, whatever you find for J, we negate it. The same thing will apply here. Whenever you found J, we were negating it. So this was 2 and this is 4. So now we are going to do the same thing on I. So we are going to do that cross thing on I. On J, and that's 1. That's 1. We will not call it J this time. That's 1 now. But yeah, we do the same thing where we use 4 times this 1 minus 1 times 5. So I will now have the number that we have here is 1. Because it should be negative, I'm doing negative 1 because that's the J1. This negative must come for the J or the one middle one. The negative must come. So it's because it is 1, I'm doing negative 1 multiplying 4 times 1, which is 4, minus 1 times 5, which is 5. So that will be equal to negative 1, the one outside, multiplying negative in the bracket is negative 1. That will give me positive 1. So that's 1. All right. Then we do the same thing for the last one. That's this guy, this remaining one, 3. So we close it like this as well. Then we'll do this time is this minus this time is this. So let me do this one there with the blue pen. That will be 3. The 3 is the number that we are crossing over. I mean our key. Multiplying, that's 4 times 1 minus 6 times 1.
Yeah.
Yeah, so that will be 3 times negative 2. That will be negative 6. So finally we had 2, 1 and negative 6. This time you just add them. You just add them finally because the determinant should be one value. Determinant is just a number that you should get. So that will be 3 minus 6. That will be negative 3. So the determinant for this matrix is negative 3. It also involves work. It also involves work. So that's why we have we need a separate session for this guy. Yeah, it's I think for 3 by 3 and so 3 by 3, 4 by 4 by 4, 5 by 5 going. This is the logic that we follow. But let me give another example for 3 by 3. Then tomorrow we'll continue from here again, from this one by determinant before we proceed. So because
sorry,
yes.
The determinant you had for this question, what was the answer?
Negative
Negative 3.
Negative 3.
Okay.
All right. So let me say I have another matrix that let's quickly find this one. Let's some random numbers. Negative 1, 2, 3, 4, 1, 0, 3, 2, 2. Yeah, let's find the determinant for this one. You need to really be careful. So just rely on your knowledge from cross products and try it.
Okay.
We should do it now.
Yeah, the B.
Yeah.
I mean, the next session to start from here and solve other examples before you go to the next concept. So, but this one, I just want to see if this one.
I think with this, we need to be getting lots of questions to be solved because the things are really confusing. Now that we are moving forward now.
All right.
Because the rules are many.
Oh, okay. Okay. I need to get questions.
I had one. I don't know that is correct.
1. Wow.
Just give us some few minutes.
All right.
Uh, so I think the
This must be.
I had 4.
okay. So let me see my own. 15, 16. I had -3.
Different answers today.
Yeah, yeah,
All right. I mean,
-3.
no problem. Let me quickly solve it. Then maybe I'll send some examples around this particular one. Then we try before next session so that it will be handy. Okay. Let me quickly. I'll be fast with this one. I'll be really fast with this one to just see confirm the answer. So 1 times this. That will be 2 minus 0. That's 2 times -1. That will be -2 for the first one. Then for the middle
Yeah.
one, that will be 8. 8 times 2, that's 16. 16, -16. Yes. Then this 8.
The first one, is it 2 or -2?
This one,
It's -2.
-2. Because it's the J, you have to negate it. But what I
Yeah,
tell
you have to negate.
No, I mean the -2. How do you get it? Maybe is it not 1 times 2, which is 2, and
1
then
times
Yes.
2.
2 times 0, which is
1 times 2
0.
is 2 minus
yes,
0
and then 2
times
times 0 is 0.
times -1 here.
I'm -1, so -1.
Yeah.
Ah,
it's
-1. Oh, I've written 1. I did the -1. Oh, okay.
Oh,
I
all
used
right.
1. Oh shit.
Sorry.
So that
So
will be
3,
-1
8,
minus 16 plus 15.
8 minus C,
That
that's
should be -2. The
50.
final
Yeah.
answer should be -2.
Yeah, so I'm right.
The answer is what? Negative
So
what?
it's -3.
-2. I copied the wrong thing.
It's -3, right?
Yeah,
Negative.
-2. That's what I got.
Ah,
No, the total answer is -3.
Rajaram is
Yeah,
-3.
First one.
I'm done. It's -3 I got.
Yes.
Ah.
David,
Okay,
what did you get?
-2 minus 16 plus 15. That's -3.
Yeah.
Yeah.
Yeah, that's it.
All right.
Nicholas.
I will send the question before I even remove my hand from this and do other things. So let me prepare the question and send right now. So yes, practice before
Okay.
tomorrow. But we'll solve some tomorrow before we go to, I think, rank and inverse of a matrix. All right. Thank you.